This is the morning of the 8th of November. A clip put up by Mentor Now. Does the Boeing 737 have another major flaw? Question mark. I don't know how much of I'm going to listen to. It's a 23-minute clip. Depends on what I hear, but you'll have it to listen through its entirety.
For Boeing 737 MAX planes with defective rudders.
A warning has just been issued about some Boeing planes with functions that could jam during flight.
The NTSB recently released an urgent safety alert affecting the Boeing 737 MAX and even some older 737 NGs. So, what's the problem now? Is it serious, and crucially, how quickly can it be fixed? Stay tuned. I know I have started a lot of my recent videos this way, but Boeing really doesn't need yet another crisis right now. As I'm recording this, the company's workers in most of its key production sites in Washington state and elsewhere are still on strike, affecting both Boeing's customers and its suppliers. But of course, the news cycle waits for no one, so Boeing now finds itself once again in the news for the really wrong reasons. Because on the 26th of September, the NTSB issued an urgent safety recommendation involving the rudder system of the Boeing 737. The document explains that under very specific circumstances, the rudder system on affected Boeing 737s could become jammed or restricted. Now, the rudder is the large flight control at the very back of the vertical stabilizer, and it normally controls the aircraft around the yaw axis, which is crucial for coordinated turning, ground directional control, crosswind landings, and also in case of an engine failure. Now, I'll explain what these specific issues with the rudder is this time, but I want to make one thing very clear before I continue. This issue has nothing to do with the rudder hardover accidents involving all the generations of the 737 that you might have heard of.
At 62, feeling...
Yeah, I did all kinds of videos on that. The servo, the rudder control servo was defective, made by Henniker. Can't remember, Henniker Hafen? I might have got that wrong.
I might go into more details about those accidents at a later point over on the Mentor Pilot channel, but what you need to know is that those events involve the hydraulic actuation of the rudder itself, which is not the mechanism that the NTSB is now talking about. So, what is this new problem all about then? Well, this story emerged after an incident which took place earlier this year, on the 6th of February 2024. It happened to United Airlines Flight 1539, operating from Nassau in the Bahamas over to Newark, New Jersey in the United States. Now, here I should stress that we still don't have the final report on this incident, but the NTSB published a preliminary report about a month after the incident, laying out the basic facts. The aircraft involved was a 4-year-old Boeing 737 MAX 8 with tail number November 47280, and it was originally built for Air Italy, who sadly stopped operating in 2020 before they could even take delivery of it. And the fact that this specific plane was originally built for someone other than United, is a key part of this story, which you will soon see. On board the incident flight, there were 155 passengers, 2 pilots and 4 cabin crew, and by all accounts, most of the flight was completely standard and uneventful. But the pilots faced an unexpected problem just after they had touched down on Newark's runway 04 right. You see, when the captain, who was pilot flying, tried to move the rudder to keep the aircraft centered on the runway, he quickly realized that the rudder pedals were completely stuck, or at least they seemed stuck in a response to the normal application of foot pressure, as he later put it. Now, thinking fast, the captain then used the tiller on the left side of the cockpit to steer the nose wheel and maintain directional control that way. The rudder pedals are also connected to the nose wheel and can steer it a limited amount, so we normally wouldn't use the tiller during the landing roll, since it can move the nose wheel very quickly and abruptly and is therefore quite uncomfortable at high speeds. Again, all of this was happening really fast, but in the end it worked out fine. ADSB data from the flight doesn't show any significant deviation from the centerline, and as the aircraft took a high-speed exit of the runway, the captain asked the first officer to check out to see if his rudder pedals worked better, but the first officer found that his pedals were basically frozen too. Shortly after this, one of the pilots, probably the first officer, gave the pedals a good forceful whack, which finally got them on stock. And after that, the captain tried his pedals again and found that they now were also working normally. Meanwhile, nobody sitting behind the two pilots had noticed anything out of the ordinary. The aircraft just continued taxiing to its gate, where everyone disembarked normally and went on their merry way, except for the aircraft, which obviously was taken straight out of service. Now initially, when the airline's engineers started looking at it, they couldn't find any obvious malfunctioning parts in the rudder mechanism. But when they downloaded the flight data recorder, they did see that the rudder had remained stuck during the landing and the rollout, and also that it had taken a pretty good amount of pedal force for the system to get unstuck. 3 days after the incident, United Airlines then made a test flight to see if the problem could maybe be replicated. And to their amazement, they found that it could. Except that this time, the pilots obviously checked and identified the stuck rudder when they were still at altitude. So after the issue had been identified, the test flight was cut short and the aircraft returned to Newark, where the crew landed safely, presumably after getting the rudder on stock again. And it was at this point that the NTSB was notified about the whole sequence of events, and their investigation into this whole thing began. Now, in addition to the NTSB itself, the investigation also involved United Airlines, Boeing, the FAA, and also a company called Collins Aerospace. And the reason that Collins were part of all of this was because the NTSB had found that the problem involved a part called a rollout guidance actuator, which had been manufactured by Collins Aerospace. When tested on the ground in normal conditions, the NTSB found that this part worked perfectly fine, which was also what the United Airlines engineers had found after the incident on the 6th of February. But when the NTSB tested the part again, after subjecting it to very cold temperatures, they found that its function was severely compromised. So why was that then? Well, we will get to that soon, but what makes this whole story particularly strange is that the part involved wasn't even being used when it started acting up, because it had actually been disabled at the request of United Airlines. So, how rare is this problem? What does this part even do? And if it wasn't in use, then what was it even doing there? Well, as you can imagine, there were loads of different stories floating around in the press when this news broke, and with the flood of Boeing-related updates, I wanted to gain a truly comprehensive understanding of the situation. So I turned to Ground News, today's sponsor and my go-to source for getting all of the angles of emerging news stories. More than 100 articles were published on the 737 rudder problems, and Ground News brings together all of these viewpoints in one place, giving you a great view of how different publications...
Oh, he's pitching one of his sponsors. We're going to get rid of that. Parker Hannifin was the other company that made the actuator for the rudder that they found when they froze it. It would reverse.
Which is where Ground News really shines. Their app and websites gives more insight into any topic.
Oh, they're still pitching. That's crazy. Let me skip it.
By the media, and you have all made it pretty clear in the comments how frustrating the lack of context and abundance of sensationalism found in mainstream media can be. So I can't recommend checking out Ground News.
Yeah, he's still pitching. Yeah, well, you want to listen to it, go listen to it.
Percent
Nothing to do with the story. Hey, he's got a sponsor. It's more than I have.
Loud guidance actuator isn't what it was doing on this aircraft, we have to talk a little bit more about the 737's rudder system. The rudder pedals on the 737 can move the rudder in a couple of different ways. First of all, they are connected via cables to a torque tube mechanism, which in turn is connected to a main and a standby power control unit, or PCU. This is a closed loop system, which means that the position of the pedals will correspond to the position of the rudder and vice versa. But there are more complications to this system, because it is also designed to reduce the amount of deflection that the pedals import on the rudder as the aircraft speed increases, in order to lower its effect and avoid large forces on the fin. And on top of that, the PCU is also incorporating the operation of the yaw damper, which moves the rudder automatically in flight to counteract something known as Dutch roll, and also to help the pilots coordinate the turns with the roll from the ailerons. But the autopilots work together with the yaw damper. So under normal circumstances, the autopilots don't actually control the rudder directly, which will soon become important. Now, there is of course a lot more to the rudder system than this, including a lot of redundancy and failure procedures, but what you need to understand is that these systems have been updated and modified several times throughout the 737's history. That includes what we did with it after those rather hardover accidents back in the 1990s, but again, those accidents and their resolution predated the introduction of the 737NG and the MAX families, so those modifications had nothing to do with this incident. But some 737s have another, separate system which can also move the rudder. And that is where the rollout guidance actuator comes in. You see, what this actuator actually is a type of electric servo mechanism. In the interim report, the NTSB described the malfunctioning part as a rudder rollout guidance servo with part number SV0730. And what this part actually does has to do with the autopilot of the 737. Specifically, it has to do with ILS approaches and autolands. Now, if you're a regular viewer over on the Mentor Pilot channel, you may remember that we generally refer to 3 types of instrument landing systems, or ILS approaches, depending on available equipment at the airport, on the aircraft, as well as certifications of the pilots. And which type of ILS that we will use depends on the weather conditions that we're facing. ILS approaches are numbered Category 1, or Cat 1, Cat 2 and Cat 3, and as the numbers get higher, their accuracy gets better, and therefore the bad weather and visibility that we can handle also improves. But in order to actually do an autoland, where the aircraft touches down on the runway all by itself, we need to do either a Category 2 or Category 3 ILS approach. In a Boeing 737, this involves the use of both of our autopilot systems, backing up each other, and as I mentioned, the aircraft, the airport and the pilots have to maintain their certification to make these operations possible. But the thing is though, these are just the broad categories of ILS approaches that we have. There are even more subcategories, so when it comes to Category 3 autolands, we also have Category 3 Alpha, Category 3 Bravo, and at least theoretically Category 3 Charlie. In a Category 3 Alpha autoland, the aircraft will basically fly itself all the way down to the runway, flare automatically and then land, but afterwards the pilot flying needs to maintain directional control of the aircraft by using the rudder pedals. So in such an approach, we would disconnect the autopilot after touchdown and then steer the aircraft down the runway, and this is by far the most common Category 3 approach. But then we have Category 3 Bravo, where the autopilot instead remains connected and will maintain directional control after the landing and during the rollout. Category 3 Charlie is essentially the same as Category 3 Bravo, except that with 3 Bravo we still need to be able to see a little bit of the runway or its lights before we land, which we don't on a Category 3 Charlie. This means that theoretically with Category 3 Charlie you might not be able to see anything after landing, which is terrifying to say the least, but in practice, as far as I know anyway, Category 3 Charlie doesn't really exist, because with visibility that is that low, even taxiing off the runway and onto a parking spot would be nearly impossible, and on top of that there would be some serious problems with fire and rescue vehicles reaching an aircraft safely under those kind of conditions if it would be needed.
This is the...
I think you're going too far with these categories.
By the way though, let me know in the comments here below if there are any new developments around this, because I might have missed something. So just tell me, and while you're down there, make sure that you leave a like and subscribe to the channel as well. Anyway, the point here is that, as I'm sure that you've already guessed, the device that enables the autopilot to maintain the runway center line after touchdown during a Category 3 Bravo landing is the rollout guidance actuator, which is an add-on that will enable the autopilot to work directly with the rudder. But the thing is, out of the many thousands of 737 NGs and MAXs in service today, only a fraction of them are configured to be able to do Category 3B autolands, and therefore most 737s don't have these rollout guidance actuators. There are different reasons for why the airlines choose to do this, mainly involving cost, available airport infrastructure, and perhaps airline-specific procedures. And for consistency in training, airlines generally try to keep their fleets configured so that all aircraft use the same systems and procedures. So remember when I said that the 737 MAX 8 in this incident was originally built for a different airline who then never picked it up? Well, as it turns out, that airline, Air Italy, had ordered its aircraft configured to do Category 3 Bravo approaches, and therefore it was fitted with all of the necessary systems to make that possible. However, as it turns out, United Airlines didn't use this system on their 737 fleet, so when they decided to pick up this particular 737 MAX and a few other like it from Boeing, United asked Boeing to deactivate this Category 3 Bravo capability. But even though this was done, the rollout guidance actuator was not completely removed from the rudder mechanism. Instead, the system remained in place, deactivated, but still connected to the rest of the rudder mechanism. Now, we don't know exactly what type of approach that the United crew were flying in this case, but it doesn't really matter, because even though it wasn't activated, the malfunctioning rollout guidance actuator still caused the rest of the rudder system to get stuck in the same neutral position that it had been during the flight. After that first test flight following the incident in February, the rollout guidance actuator was then removed and the aircraft was test flown again. And this time there was no further problems affecting its rudder system, so basically problem solved. Now, following even more checks, United ultimately returned the aircraft to service on the 22nd of February, 2 weeks after the incident. But what was it that had actually happened to that part? Well, as it turns out, the part had literally frozen in position. It appears that moisture had made its way inside the part, which then froze when subjected to the low temperatures at cruise altitude, and after that had happened, the tolerances within the part were tight enough to jam everything else until enough force was applied to break it free. Now, as I said earlier, the NTSB subjected the problematic part to super low temperatures on the ground, confirming the problem, and when they repeated the test with an identical rollout guidance actuator from a different aircraft, the same thing happened. To be clear though, this wasn't a problem with the design of the rollout guidance actuator. Moisture shouldn't have made it into the part in the first place, and the reason it did was because the component hadn't been assembled properly. Collins Aerospace subsequently reported that a sealed bearing was incorrectly assembled during production of this actuators, leaving the unsealed side more susceptible to moisture that can freeze and limit rudder system movement. Collins also notified Boeing that the same assembly issue may have affected a total of 353 rollout guidance actuators, which the company had delivered to Boeing since back in 2017. And the fact that this goes that far back means that the affected aircraft could include both 737 MAXs and all their 737 NGs. Now, it seems like United Airlines actually had a total of 9 737 MAX 8s with the faulty part installed, and these 9 jets were the only ones with these particular problems in the United States. According to Dominic Gates in the Seattle Times, airlines in the US actually took delivery of 16 more 737s with the same affected parts, but these jets were then leased out to other airlines outside of the United States. But neither the NTSB nor Boeing have so far revealed how many of the 353 affected components actually made it onto operational aircraft. So some of them might still be sitting in drawers used for spare parts, for example. But on the 30th of September, the NTSB stated that as many as 40 airlines outside of the United States could have aircraft with these parts fitted. Now, since that incident, United has removed these components from the rest of its fleet, and as I already said, the interim report identified the role of these parts quite early, already back in March, which should provide plenty of time for affected aircraft everywhere to already have been taken out of service and rectified. But that's of course assuming that all operators of 737s worldwide actually know that their aircraft have these parts. That's why the NTSB wants to see more action on this issue, adding that 2 other airlines suffered similar problems with the 737s as early as back in 2019.
If you're trying to...
One of my contacts that I made is a 737 captain. I sent him this article yesterday. This is scary, folks. See what a little bit of moisture can do on a proper bearing seal? It's insane. I'll attach the link. Look at it. Pass it along. And thanks for listening.